Hello class, this is a video tutorial on Venn diagrams and set notation. So previously we've seen the basic concepts for the notation and diagram of just two sets. So here are a few combinations of unions, intersections, and complements between any two sets A and B. By understanding the set notation concepts, we can interpret and or draw Venn diagrams with three sets. So before we move on to three sets, let's just really get our heads around just single sets and double sets first. So when doing this on pen and paper, the best way to go about this is, rather than sketching it like so, simply draw, and I highly recommend using a pencil for this. Just drawing a line, just lined things such as this, being very careful to go right to the edge of what you're trying to indicate. This is, well, what I'm showing you here now is actually all of A. So whenever you see a letter, we take everything inside the Venn diagram or the circle of A. So you can do it this way, or you could grab a highlighter and really carefully highlight the inside of all of A. Okay, so I'm not going to be doing this method, but on pen and paper, you can, remember, use lines like so, or a highlighter. But for this, I will be using the features of my iPad. So here we go. For A, we just want everything inside of A. So, like so, there we have it. For B, well, it's everything on the inside of B. And for C, we want everything on the inside of C. These are the very basic single set notation Venn diagrams. Let's now take a look at not A. Well, to find this, it is, well, if we can visualize what's in A, we are looking everything outside of A. So it'd be something like so. So using my iPad for this, it'll be something such as this. It'll be, oops, this orange. It'll be everything on the outside of A. Being very careful here. There we have it. That is not A. Well, since we know it's going to be the same for all of these. A, not A. Well, for B, same thing. So not B is everything outside of B. Let's prepare that for C as well. Oops. Line up, please. There we go. Everything outside of B is not B, or the complement of B. Let's make these orange. So not B is everything outside of B. And not C, well, it's everything outside of C. So these are the six very basic, well, three, and the complement of each of these. So let's move on to the next. Remember, with union, we accept both A, or whatever letters, A and B, so A or B. So we take both groups. So all of A and all of B, including the overlap. So it'll look something like so. So all of A and all of B. And even if it looks like it's highlighted darker, it doesn't really mean anything. It's just taking everything on the inside here. So that's A union B. Now let's take a look at the intersection of B and C. Now, the reason why I've shown all of these basic ones, the intersection of B and C, we look at B, we look at C, and we find the region that is the exact, well, that is overlapping the two. If you can see, this region here, these are overlapping in both B and C. So highlighting that, it will be something like so. Be very careful to erase, oops, erasing the bits on the outside. That is B intersect C. And now here's where it gets rather interesting. It is not A or B. Remember, for this, with unions, we look at everything in not A and combine it with everything in B. So take a look. Everything of not A and everything of B. If I were to now just show that here, so this is everything in not A, and this is everything in B. When we combine it, it's this bit here is the only part that is not included. So notice even this region here is doubly counted, but that doesn't matter. The region we're looking at here is that one. Okay, let's move on. Now, if you look at these, it is the complement of everything in this column. Well, now consider, since we have A union B, this is not, or the complement of A union B. Well, simply looking at this graph, this set asks for everything that is not inside here. Give you a moment to visualize what this looks like and even highlight or shade in what you're looking for. It will actually be something like so. Make this orange. Moving it in. So it is everything not, so it's not this group. Well, since we have this group, oops, since we have this group, it's everything outside that group. Well, it'll just be everything outside that group. Notice again how if you were to combine these two, so if I were to then just overlap like so, it fills in the bit that we've just erased. Okay, so that is the complement of the previous row. Remember that when we are doing the complement of any group. So take a look again. B intersect C. In this one, we're looking for the complement of B intersect C. Well, since we have B intersect C, we're looking for just everything outside that group. So highlighting that, it'll be everything that is not that group. So I'm just going to erase the bit that we don't need. Whoop, erase the bit that we don't need. It's a little bit larger there. Erasing the bits that we don't need. That is the complement of B intersect C. Remember, once again, this is just the complement of this on the previous column. Well, since we know what this looks like, I'm sure you can visualize the remaining bits, so everything outside or that is not in this group here. So let's grab this. Here we go. Remember, we are highlighting everything that is not highlighted here. Well, oh, actually, it didn't need this. It's actually just, oh, being very careful here, just the inside here. Actually, I could do this. All of this, but I'm going to erase the bits that we don't need, like so. So notice how if we were to combine these two, it'll be everything. Now let's try these last three, this last column here. If you look very carefully, this and this are complements of one another. So if you can visualize what this looks like, once you get this correct, it is very simple to get this one. Well, let's consider now, because we have all the basic ones here, not A intersect with C. So look at these two graphs here and consider what is the same in both. So what is the same in both? If you just visualize this one, well, a little trick for this is if you actually highlight like so, so this is not A. If you then again highlight in a different color, actually let's use a different color here. Let's do this one in green. If I then were to take C and highlight all of C, you can see that there is a portion there that is doubly highlighted or colored in both colors. So it's actually this one here. That is the same in both these groups. So seeing that, we are looking to highlight what is the same. I'll just erase the bits in the end. What is the same in both groups? So it'll be something like so. Oops. One more time. Be something like so. That is not A intersect C. Well, now that you know what this looks like, I'm certain you know what this should look like. So it's everything that is not in this group here. So quickly highlighting this, it'll look something like so. Just looking back to our previous, everything that is not inside this. Well, for that, it's just simply, let's just erase the bits that we don't need in this one. It will be something like so. That is the complement of, so the complement of not A intersect C. Well, now that you have all of these, this one is unique. There's nothing here that looks like this. So you can pause and just wait for the answer here, or give it a try it yourself. So I'll take you through how we construct this. So not B combined with or, so not B or not C. So we're going to combine those two. So visually I'm doing this. Not B and not C. I'm just combining everything. There you go. So I've overlapped the two. That is not B. I'm now putting not C. I've just combined everything. But now I want the complement of that. So whatever we've just found, we want the inverse of this. Well, as you can see, we've combined everything. The inverse is everything on the inside like so. So it's actually everything on the inside of that shape. So that is the complement of not B union not C. If you actually take a close look, that is actually equivalent to these ones. So there's actually equivalent Venn diagrams and set notations. Okay, so I hope that's given you an insight. Oh, what happened on this one here? Well, don't know what happened on that one, but I hope that's giving you an insight into how to construct Venn diagrams based off these three basic ideas. I'll see you in the next video where we take on actual three, well, sets of three set notations and Venn diagrams. Hope to see you then, and best of luck.